So I want to wrap up the section on solving these equations by looking at a couple of examples that demonstrate those two outlier situations. One is where we have an inconsistent system, and that's where you have no intersections. And the other is a dependent system. Okay, and that is where you have an infinite number of intersections. So let's look at each of these. Here we have negative 4x plus y equals negative 8, and we have 4x equals 8 plus y. Okay, so let's go ahead and let's see if we can try and write this in a way that makes it look like a more normal system of linear equations. I guess let's just move this y over to the other side, and that's going to give us negative 4x plus y equals negative 8, and then we have 4x minus y equals positive 8. Okay, I think this looks like it's a pretty good candidate for addition, just basic addition. We don't have to multiply anything or anything. We can just go ahead and add them together. And if we have negative 4x and 4x, that's going to be 0. Okay, and we have y and negative y, that's 0. And negative 8 and 8, hey, that's also 0. So we have, in the end, 0 is equal to 0. Okay, so if you end up doing some process of elimination, or you do substitution or something, and you end up with 0 is equal to 0, or some true statement like that, y equals y, x equals x, 5 equals 5, doesn't really matter. Some kind of true statement where you've eliminated all the variables, you will say that these two equations they are dependent, okay? And that would mean that there are infinitely many solutions. So we can write infinity solutions, okay? And we can also say that these are dependent. Okay? They're infinite solutions and they are dependent. They're dependent on each other. You're actually looking at a different representation of the same line. To see what I mean by this, let's just go ahead and say, let's take this line here and multiply it by negative 1. So if we multiply it by negative 1, we'll end up with negative 4x minus y equals negative 8. And hey, that is the same thing as this line here. So we're actually just looking at a different representation this should be plus, I'm sorry. This should be plus. My bad. Okay, so we have negative 4x plus y equals negative 8. So we're actually just looking at a different representation of the same line. So we would say that these are effectively the same line, and they are dependent. And we have an infinite number of solutions because they are constantly intersecting each other. Okay, let's look at this one. Here we have x minus 5y equals 5, and we have negative x plus 5y equals negative 5. Okay, well, let's go ahead and add 5 to both sides here. And that's going to give us x minus 5y equals 5. And we have negative x plus 5y equals 5. Okay, this looks like a pretty good candidate for addition again. So if we add them together, we'll get x minus x is 0. And we have negative 5y plus 5y, that's also 0. And then we have 5 plus 5 equals 10. Or we have a statement that looks like 0 equals 10. And we have a problem here because this is not true. Okay, can't stress that enough. That is not true. 0 equals 10, that is nonsense. What this means, if you end up with some kind of a nonsense statement like 0 equals 10, we know that's not true. So that would imply having no apples is the same as having 10 apples, and that is not true, right? So we would say that this is not a true statement. Therefore, we have that this is an inconsistent system. Okay, it's inconsistent, and there is no solution. So it's the opposite. So we would say that these two lines are parallel. So if you remember, what would be another way we could confirm that these lines are inconsistent? Okay, one way to do this would be to see if they have the same slope and a different y-intercept. So let's go ahead and do that just for fun, just to do a little callback here. So if we solve this top one here, we could turn this into Okay, well, let's bring this down here. So we have x minus 5y equals 5. So we could take x away, all right? And then that's going to give us negative 5y is equal to negative x plus 5. So if we divide both sides by negative 5, we'll end up with y equals negative x over negative 5 plus 5 over negative 5, or we have 1/5 x minus 1. Okay. And then for the other one, we have negative x plus 5y equals 5. Okay, so we can add x, and we'll have 5y is equal to x plus 5. So we can divide both sides by 5. And that's going to give us y is equal to 1/5 x plus 1. Okay, so these have the same slope, but a different y-intercept. This one has -1, the other one has +1. So you'd say these lines are parallel, but not the same, and therefore they are inconsistent, meaning they don't ever intersect. They are parallel lines. So we would say they're inconsistent and they have no solution. Okay? You don't have to check they're parallel the way I just did. This is just a reminder of how we check to see if two lines are parallel. Okay, we've covered this before. So just a friendly reminder about how that works. So by no means do you have to do that when you're doing your homework, but good to remember what to do, right? So yeah, hopefully this is helpful when it comes to solving these types of equations.